Well, our third example of division of polynomials is once again a long division problem, but this problem has a few more little quirks that we need to be careful of, and we'll point those out as we go through the problem. So, as we did before, we're asked to find the quotient and remainder from the division given by the problem listed here. Negative 11x squared plus 3x cubed minus 1, all divided by x minus 3. The first thing we might notice is that we have the wrong order for our dividend, and when we're setting up our long division problem we need to make sure the dividend and the divisor both are from highest power of x to lowest power of x, including the constant. Also, as we look at this, we might imagine, and we hopefully would notice as we write our problem down, that we have a power of 3 for x, a power of 2 for x, but we have a missing power of 1 for x. X to the first power does not appear in the dividend. So as we're doing our problem, we want to make sure that we set up the long division correctly. So first let's write down our divisor, x minus 3. And we set up our long division symbol. And let's write down our dividend in the correct order underneath. Let's see, that would be 3x cubed minus 11x squared. Now, since we have a missing power of x, x to the first power, we compensate for that by saying plus the coefficient 0 times x. After all, 0 times x is just 0, and when we're adding 0, we're really not changing the dividend at all. And of course, don't forget our minus 1 for our constant term. Now let me also point out that if we had a missing power in the divisor, we would do a similar thing, and even if we had a missing constant term, we might include a 0 for the missing constant term. Okay, once we've done this, we start the problem as we always do. What do we multiply x by to create 3x cubed? And of course that's 3x squared. We have a column for x squared terms. So we write our 3x squared here. And then we actually use this 3x squared to multiply the whole divisor, and we'll do that one term at a time. 3x squared times x being 3x cubed. 3x squared times negative 3 being 9x squared. Okay, now we do our subtraction, and of course this is always the tricky step, and we need to be very careful the way we do this step. Remember, we're going to take the polynomial on top and subtract the polynomial on bottom, but we can actually do that one term at a time. So we look at the term negative 11x squared. That's the term on top, and we're going to subtract the term on bottom, which is a negative 9x squared. And as we've discussed before, we don't consider this the subtraction sign when we're doing this step. It's part of the term negative 9x squared. So as we see that as we do this, we end up with negative 11x squared, actually plus 9x squared. And we probably could have done that in our head. We know that result, of course, is negative 2x squared. So this subtraction, the subtraction we have out right here actually results in negative 2x squared. Of course, I didn't mention it, but 3x cubed subtract 3x cubed was 0, and we just left that 0 off. Now we'll bring down the other terms, which will be plus 0x minus 1. After all, we're subtracting 0 from each of those. Then we begin again if we need to continue. And since the degree of this remainder is higher than the degree of this divisor, that means we should continue. So we ask the question once again, what do we multiply x by to create negative 2x squared? And that, of course, is minus 2x, or negative 2x. And hopefully, or thankfully, in this case, we have a column for x's because we put in our 0x. If you ever run into a situation where you need a column for a term that you're adding to your quotient and it's not there, then you've probably set the problem up incorrectly. Once we have this negative 2x, we use it as a multiplier on the divisor, one term at a time. Negative 2x times x. Of course, that was the negative 2x squared that we were trying to create. Then we have negative 2x times negative 3, and of course that's plus 6x. And then we set up our subtraction once again. And notice, since these are like terms in each case, that we can really think about dealing only with the coefficients. Pardon me. So we really have a 0 subtract 6, which of course is negative 6, but that's the coefficient of x. So negative 6x, we bring down the minus 1. Then we compare the degree here, which is 1, with the degree here, which is 1, so that means we continue. We continue until this degree is smaller. So what do we multiply x by to create negative 6x? And of course that's negative 6. And we have the column for constants, and that's where we put that in our quotient position. So now it's negative 6, times x. That's our negative 6x. And it's negative 6 times negative 3, which is positive 18. And now we subtract again. Of course, negative 6x subtract negative 6x is 0, because that becomes negative 6x plus 6x. Now, in the second position, we have a negative 1. We have a negative 1. And we're subtracting what's underneath, which is 18. So when we do that subtraction, of course, we get negative 19. So this position ends up being negative 19. And then we consider whether to continue. Well, the degree of a constant is 0. The degree of this polynomial, the divisor, is 1, and so this degree of the remainder is smaller than the degree of divisor. That's when we stop. So we see this problem, this division, gives us a result, or a quotient, that we have here, 3x squared minus 2x minus 6, with a remainder of negative 19. Now I've recorded that ahead of time. There's our quotient and our remainder. And I want to remind you that we had discussed previously that another way to write an answer other than just quotient and remainder when we have a division is we can say that that division, that result, is the quotient. Okay, so here we have the quotient. Make that clear. The quotient plus the remainder made a mess of that, divided by, of course, the divisor right here, the divisor. So that's another way that we may sometimes be asked to leave an answer, rather than just writing the quotient and remainder, rewriting the result in this fashion. Now, we also learned how to check a problem, a division problem, when we have a remainder other than 0. So let's remember how that looks. So in this case, we had the remainder. Now, when there's not a remainder, of course, it would just be, the check would be divisor times quotient, of course, plus 0 remainder, or just divisor times quotient, has to be equal to the dividend. So the way we many times, of course, do our check work, kind of running off the page here, but we would take our divisor, in this case x minus 3, we would multiply with our quotient, of course, 3x squared minus 2x minus 6, and then we would add our remainder, negative 19. We would do these operations and ensure that we get this result, which is the dividend.